Okay, so this video is going to go over this written question, perfect and deficient numbers. And I am going to make this just a little bit larger. So hopefully there's no problem with video quality. At least you can see it a little bit better, I think, if it's a little bit larger. Alright, so perfect and deficient numbers. So a positive integer is called a perfect number if the sum of all of its factors, excluding the number itself, i.e. its proper divisor, is equal to its value. For example, the number 6 is perfect because its proper divisors are 1, 2, and 3. And 1 plus 2 plus 3 equals 6, but the number 10 is not perfect because its proper divisors are 1, 2, and 5, and 1 plus 2 plus 5 is not equal to 10. So a positive integer is called a deficient number if the sum of all of its proper divisors is less than its value. For example, 10 is a deficient number because 1 plus 2 plus 5 is less than 10. While 12 is not because 1 plus 2 plus 4 plus 6 is greater than 12. So this one's less than 10, this one's greater than. So write a method called isPerfect where you pass in a positive integer that takes a positive integer value and returns true if the number is perfect. And so these are different test cases you can use. I'll focus on this one because I already gave you guys the 6, so let's just look at this one when we do this. And then it says write a method called isDeficient, and you pass in the same positive integer that takes a positive integer and returns true if the number is deficient. So 2, 3, 4, 5, 7, 8, 9, 10, 11, 13 are deficient numbers. Okay, so let's look at this perfect one first and think about how to solve this. So if I got 28, what are its factors? So its factors are 1, 2, 4 times 7 is 28, so 4 and 7 work. 3 doesn't work, 5 doesn't work, 6 doesn't work. And I guess half of it, 2 times 14 would be 28. So 1, so basically this is what, 1 plus 2 plus 4 plus 7 plus 14. So does that equal 28? So 21, 25, 26, 27, 28. So we'll focus on that. So what you have to do is you got to do a loop that runs through each number in 28 up to half of it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then 14. So let me think here. So why did I go to 14? Well, again, you can't use the number itself, and so then I guess half of it would be 14. So 2 times 14 is 28. So half of its number would be you'd able to at least multiply it by 2. So now we got to extrapolate which ones are its factors. And so in order to do that, you got to figure out. I would use modulus. I would take whatever number you're on, 1 and 28, and use modulus to see how many times does 1 go into 28, and then its remainder. If its remainder is 0, then it's a factor. So 2 goes into 28 14 times with the remainder 0. 3 goes into 28. What would that be? 3 goes into 28. That'd be 8 times. 8 times 3 No, it'd be 9. It would go 9 times, so 9 times 3 is 27. So you'd get, 28 minus 1. So here, let's just write this out so you don't get confused. So 3 times, 3 times 9 equals 27. And then if you did your math, that 28 minus 27 gives you a remainder of 1. So 3 doesn't work, so you chop that off. 4 does, because when you modulus 4, 28 modulus 4, you get 7 with the remainder 0. So you're going to have to run through each one of these numbers and find which factors based off of using the modulus operator. So let's write this method first, and then we'll write the deficient number one next. All right. So we're going to have to ask the user to import, to put in a number. So import java.util.scanner. So I'm gonna do perfect numbers, my perfect numbers equals new perfect numbers, and then we'll do scanner, my scanner equals new scanner. System.in. And then we'll have to ask the user system.out.println. Please enter a number to determine if it is a perfect number. And so in order to be able to view this on the screen, I'm going to get this to come down here a bit. Okay, and then so I would just call this int positive int, like it asks me in the description, the problem description. So I'd say my scanner dot next int. And so it's supposed to spit out, let's see what it's supposed to return. So write a method called isPerfect that takes a positive integer and returns true. So I'm actually returning true or false for both of these, all right? So I'll say system.out.println. So it sounds like they just want me to create an accessor method and not a mutator method. So I'll just create isPerfect as a mutator, and that's fine. The number is perfect. And then plus my perfect number, my perfect numbers dot is perfect, and I'll pass in up the positive integer. Okay. So there's an error there, so we got some creating to do. So it's going to return true or false, so I'll say public, and instead of void I'll say boolean, because that's what I'm going to return, a true or a false. Public boolean is perfect, and I would accept the positive int, and up here I'll int my positive int. So I'll say my positive int, my pos int equals pos int, and I need a semicolon there. What's wrong with this? Pos int. What's wrong with this? Missing return. Oh, okay, yeah, duh. So it's going to return true or false, all right? So we'll get to that in a second. So, we will be adding up all these numbers to get this. So we're going to need to have something to hold all these numbers that are getting added up. So I am just going to call it the perfect total. And so that's that for now. So let me think here. So, again, we've got to do a loop going from 1 to half of this. Or you could just do 1 to this number. It's not that big a deal. It's just, you know, it might go faster if you just only go to half of it. I don't know. Let's just, instead of messing around with we could just do 4 int I equals 1, and I would be less than the pos int. So you could do it like that, I plus plus. So this would go from 1 to the value right before it, and so that would never work. So I mean, you could do that. You could do that, or you could do less than or equal to my positive int divided by 2, and that would give you your half of it, and it'd be 14. Either way, it doesn't really matter. I'll just keep it like this. Let's just try it like this, and then you know, it's really that gets to more style, I guess. I mean, I guess the other way is a little bit faster maybe too, but I guess let's just keep things simple with going to the end here. Now, you don't want to set it equal to that because 28 is a factor of 28, and it would return 1 with the modulus of 0, and that would not be what you want to do. So you need to make sure it's less than 28 right here. So all you do is just say if my pos int, so whatever, you know, that's 28, modulus where you're at an I, if that returns a 0, then that's a factor of, you know, in this case 28. So is 1 a factor of 28? Well, how many times does 1 go into 28? It goes in 28 times with a remainder of 0. So it is. So we need to add in I to our perfect total variable. So we would click right there. I copied and pasted it, and I would just say plus equals I. And then I would be increased by 1, so I would become 2. Does 2 is 2 a factor of 28? Well, how many times does 2 go into 28? It goes in 14 with the remainder 0. So that's true. So this would change to 2, and this was already 1. So 1 plus 2 is now 3. And so then we go to 3. Is 3 a multiple of 28? Nope. So we'd skip it, and then go to 4. Is 4 a multiple of 28? Yep. So it gives a remainder because it's 7, and it gives a remainder of 0. So then you would add 4 in there. So you got 1 plus 2 plus 4, and then you would just keep going through this. So that gives you your perfect total. And so if my positive int, so 28, is equal to the perfect total, if they're equal at the end, then return true, else return false. Okay. So let's run this real quick and see if it works. Should be good. And I can't remember all the numbers here. We're going to test more than 2 of them. But let's get this started and see what we got. So let's start with like the number 4, because 4's multiples are 1 and 2, right? So we'll say 4 here. That's false because 1 plus 2 is 3, and that's not 4. But let's try 6 now. It's perfect. How about 28? It's perfect. It's true. How about 27? It's false. How about, what is this? Is it 496? Whoops. Okay, so it looks like it's testing okay. You know, how about 8? 8 would be 1, 2, and 4, right? It's false. Okay, so I think that's good. All right, so next up, we got to do the isDeficient. So we'll do same thing as here. It's returning true or false, I believe. Copy and paste, and we'll say the number is deficient. deficient and isDeficient is our method. So let's read this one more time. So a positive integer is called a deficient number if the sum of all of its proper divisors is less than its value. For example, 10 is a deficient number because, okay, well 12 is not because it's greater. It's okay, wait a second. Let me think here. Well, I didn't actually build this perfect. Ideally, this is this is all the exact same code. So I should have built this in a separate method to get the perfect total value, and then I could have just did isPerfect with this, and then let's see here. Public Boolean isPerfect is deficient. Because it's basically the exact same code, almost completely. Only instead of equal, we'll just say that it is. If this is greater than that, then you return true. Else you return false. So that's, you know, that's probably an error on my part, and in order to fix that, I could just have written one method, and you know, I could have created variables for true and false, and said, you know, if this is true, and I could have checked to see if this is true, or if this is true, then assign this to true. And I don't know. There's different ways that would have been a little bit more efficient to save code, but this should work as well. Let's check it out because they give us examples. So takes a positive integer and returns true if the number is deficient. So these are all deficient numbers. So let's try 2, 3, 5, and 7. So 2 is false. 3. Did I do it right or wrong? Let's see here. Deficient. 3. And true if the number is deficient. Ready? It takes a positive. These are all deficient numbers, so they should return true. Was 2 deficient? False. That should be true if this thing's right. Because let's look at this real quick. So if the sum of all of its proper divisors is less than its value. So I've got an error somewhere. What's my error? Let me just make sure here. System.out.println. And this is where this is good to actually, so my pos int, and then plus my pos int, and then system.out.println, perfect total plus perfect total. Let's check this out real quick. So 2. So 2 and 2. So right here is this greater than that. That would be false. So maybe I wrote that in wrong. Maybe 2 isn't. So write a method called that takes a positive integer and returns true if the number is deficient. 2, 3, 4. So that is deficient then. That is true. Okay. But then what did I get for 3 real quick. And let me do this too, because I like to narrow it down. We already tested that. We know it works. So we run this. Let's try 3. My positive int is 3 and 1. So 3 is greater than 1. How about 4? 4 is true. 4 is greater than 3. So with 4 you got 1 and 2. So I think I might have written that. Yeah, that didn't. Let me look and see what are examples of. So, for example, 10 is deficient because that is less than 10. Why 12 is not? Let's try 12. 12 should say false. 12. Deficient, false, but 10 should be good. So, yes, that is deficient. So, I think we're good on this. So we just tested and just made sure that these were right. So I think we're fine. So again, did 3 come up weird? Because 3 would just be 3 is deficient. Yeah, it is deficient because 1 is the only multiple of it, and so that is greater than that. So that's true. All right, so I think this is done. I think we tested it pretty good. Go through and just kind of look at this again. The biggest thing when you're working with loops and this type of stuff is you'd have to start from the beginning and go all the way to the end and then figure out your algorithm so that only these numbers would be spit out for 28, just the multiples. And again, you would do that using this modulus operator and figuring out the remainder. So again, I think this is a program that you guys could do pretty easily if you had to write it out with the computer and got to test it like I've done here. It's another ball game when you're having to write it out and figure it out off the top of your head. So again, try practicing this kind of stuff on paper, and you know, because this could possibly be, you know, an AP style question that you would get at the end of the year. And again, I think most of you could get most of this, you know, which would give you like maybe a 3 on the actual problem. But are you able to push through and get that 4 or 5 score on this? That's where our goal is to get to by the end of the year. So this video is